Two triangles can be proven to be congruent without having to show that all corresponding parts are congruent. What we're going to start with is the side-side-side postulate, or the SSS postulate. The side-side-side postulate states, if the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So as you can see, we have, if segment AB, or side AB, is congruent to side XY, and side BC is congruent to side YZ, and side AC is congruent to side XZ, then triangle ABC is congruent to triangle XYZ. Now, all that means is that the three sides of one triangle are congruent to the three sides of another triangle, then we have two congruent triangles. That's all that means. So let's look at our example here. We are given that segment BC, or side BC, is congruent to side BF. So let's go ahead and mark that. Side BC is congruent to side BF. And that side CD is congruent to side FD. So let's mark that while we're here also. Side CD is congruent to side FD. We have to prove that these two triangles in this picture are congruent to each other. So our first statement is side BC is congruent to side BF, which we marked, and side CD is congruent to side FD. First reason is given. Now if I look strictly at the picture, what I have is side BD, which is in both triangles. Well, the reflexive property allows us to state the side BD is congruent to side BD. So that's our second statement and reason in our proof. So let's go ahead and mark that on the picture also. Side BD is congruent to side BD. Now if you'll notice, in the one triangle, we have three sides congruent to the three corresponding sides of the other triangle. So now we can say that triangle BCD is congruent to triangle BFD by the side-side-side postulate. That's not the only postulate we have. We have another postulate called the side-angle-side postulate. This postulate says, if two sides of one triangle and the included angle, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So what we have is, in our picture, side AB congruent to side XY, angle A congruent to angle X, and segment AC congruent to segment XZ. The included angle, angle A and angle X, these included angles are the angles that form the two congruent sides. If you look at the picture, it looks like you could kind of say that they're in between the two congruent angles, the two congruent sides, I mean. The included angles are between the two congruent sides. Let's look at our example. If we're given that segment BD is congruent to segment DA, or side BC, is congruent to side DA, and angle CBD is congruent to angle ADB, then we have to prove that triangle BCD is congruent to triangle DAB. Well, let's mark what we have. Side BC is congruent to side DA. So side BC is congruent to side DA. And angle CBD, this angle right here, is congruent to angle this angle right here. We've marked all that's been given. Now look at our picture. Again, we have a shared side between the two triangles. This shared side is in both triangles, so we can say that side BD is congruent to side BD by the reflexive property of congruency. So let's go ahead and mark that as well. Side BD is congruent to side BD. Now if we look at triangle BCD, we have this side congruent to this side. We have the angle that is included between the two congruent sides, congruent to each other, and we have another side congruent. This says that this triangle is congruent to this triangle by side, angle, side. And that's how we prove triangles congruent.